Hello.
Hello.
Again, I'm Mrs. Holyfield,
I'm Mrs. Bauer.
and today we're going to go over uniform motion, and I'm going to act as the teacher, and this is my student, Miss Bauer. So hopefully this will help if you were absent. You can watch this over and over again, or if you just need a reminder about what exactly went over in class, here it is.
Yes.
So we have a fire truck here, and it's moving in uniform motion. What do you think that word uniform might mean?
It means like what I'm wearing, a uniform.
Yeah, well, it could mean that.
It means all the same.
Exactly.
That's why we're all wearing uniforms.
Good. And so that fits right in with constant velocity, which is the unit that we're going over right now. So let's say we have this fire truck, and we see that the fire truck it travels 60 centimeters and in 15 seconds.
All right.
And then we take some more data, and we see that it traveled 60 more centimeters, and it took 15 seconds. Does that seem pretty uniform to you?
Sure does.
Okay.
Yeah.
So this fire truck would be traveling at a uniform motion or constant velocity.
Okay.
So we have these numbers, 60 divided by 15 equals 4. What do you think that could mean? What could that stand for?
Well, if you look at the units, it'd be centimeters over 15 seconds. So centimeters per second.
Exactly. So we have a rate of travel, which is centimeters per second. And in this case, our fire truck is moving 4 centimeters per second. Excellent. So velocity. We're going to go over the operational definition. I'm going to see if you remember. Do you remember what velocity is?
Centimeters per second.
Okay. So what is that a measure of?
Speed?
Close, but not quite.
Speed with direction?
Yes, exactly.
Yay!
Remember that velocity is a change in position, or also known as displacement, over a change in time. And that little triangle means change in. So just if you forgot that.
Cool. Thank you.
So we have 3 flavors of velocity, if you will. And
Vanilla.
The first one we're going to talk about is uniform.
That's very vanilla.
So graphing uniform motion. So we can take the data that we took or saw with the fire truck, and we can actually create a graph out of it.
Cool.
A graph is a collection of points. So
I like math.
I know, me too.
Awesome.
And it comes to life through physics.
That's even better.
So if we have our fire truck and the truck is at the position 0, we want to start 0, 0, right at the origin.
Okay.
So where do you think our next point will be if the fire truck traveled 60 centimeters in 15 seconds?
Well, T is the time axis.
Okay.
So it would be over 15 seconds.
Uh-huh.
And then it's weird because change in X is now the vertical instead of change in Y. So I'll go up 60 centimeters in the vertical.
Excellent. So our next plot is right there. And then we know, because we already talked about this, it goes 60 more centimeters in 15 seconds. So what do you think that'll look like on our graph?
60 plus 60 is 120. And 15 plus 15 is 30. So since time is on the horizontal, you go over 30 and then go up to 120.
Yes, good job.
Thank
you were paying attention in class.
I was, Miss Holyfield.
Okay.
Mrs. Holyfield.
So what can we do to give this a little bit more meaning?
We connect the dots.
Yes. So now we have a line, and that line means something.
It does?
Yes.
What does it mean?
Well, do you remember what these diagonal lines are in math? Do you remember what they're called?
A line.
A line. Well, the symbol was M.
Oh, the slope of the line.
The slope of the line. Good. So our slope here actually means something. It has value.
So we're not just finding it because they told us to.
No. You're actually finding the slope for a reason. Because do you remember slope is rise over run, right?
Yeah.
So if we're trying to find a rise over run, that's basically a rate of something.
Okay.
So on a position time graph, the rate is the velocity. The slope is the velocity.
Ooh.
Because if we look closely, the slope, which is rise over run, the rise is change in position, because position is is our,
And change in position is our displacement,
yes.
and velocity is displacement over change in time.
Exactly.
Yay!
So our slope tells us the velocity on a position time graph.
Oh, that is so awesome.
Yes, it is. So in this case, we can actually pinpoint the velocity because
And look, we don't have to use the dots that are given. We could just use any two dots on the line.
exactly.
That's really helpful.
Yeah, good point.
Yeah.
Good job. So here, our rise is 60. And what do you think our run is?
Well, we go from 10, they're not going to see me pointing at
Oh, 10.
10 to 25, so that'd be 15
Excellent.
seconds.
Good. So when we calculate our slope, we're going to do rise over run, which we already knew this, but we can prove it here on the graph, 4 centimeters per second.
Ooh,
Excellent.
very good little toy truck.
Yep. So,
Oh, interpret 15 divided by 60. Well, that'd be seconds per centimeter, but we don't have a name for that.
no.
But it still has meaning.
Mm-hmm.
So every centimeter it takes 0.25 seconds to go that
Yes,
distance.
60
So
centimeters.
just because we don't have a name for it in physics doesn't mean it doesn't mean something. It's just we don't use it very much.
Exactly.
Okay.
Good. Do you have any questions?
Can I get some examples and so I can learn a little bit more how to do this?
Yes.
Oh, thank you. Let's just draw.
Okay.
Okay.
Wait, what am I?
Oh, here. Okay, so could you tell me oops. Okay. Could you tell me something to graph a kind of motion, and I'll try to do it as practice?
Sure.
Okay.
What if we had time, position, good. What if we had a dog?
A dog.
And the dog
All right.
starts at position 0.
I'm gonna try and draw a dog.
Okay.
This is a bad dog. Oh well.
Sleepy dog. So the dog starts at position 0, and the dog travels 2 meters per second
Okay.
for 3 seconds. Can you draw that?
Okay. Does he go in the positive direction or negative
Good
direction?
question. The dog right now is going in the positive direction.
Oh, wait, oh, dang. All right. Let's see. Oh, maybe I want that one. Okay, yes, I want that one. For 3 seconds?
Yes.
For 2 meters per
2
second?
meters per
So-
second.
2, 4, 6. This is meters. And this is seconds.
2 meters per second for 3 seconds.
Okay.
Excellent. Then the dog gets tired, so he stops for 3 seconds.
Okay, so stops mean no velocity. So
Good.
he's staying at the same position.
Exactly.
And so 3 more seconds, so now we're at 6 seconds.
Yep.
Okay.
And then he decides that he needs to go back to where he started from. But he's going to go a little faster. He's
Okay.
going to go, what did we do at first? He's going to go 3 meters per second.
Oh, okay. All right.
Yay!
And so since he's going 6 meters back at 3 meters per second, that only took 2 seconds.
Yep.
So now we're at
8 seconds. Good
Yay!
job. Excellent.
And we have to be careful because to me, when I see this, I think we're going up a hill and down a hill.
Exactly. But that's not the case because the dog, I didn't say a hill, right?
No.
I just said he's going in a positive direction.
He's just going forward, stops, and then goes backwards.
Exactly.
If we were to do a motion map,
Mm-hmm.
how would that look?
Good question. So do you remember that a motion map deals with a number line?
Yes.
Starts with a number line. And there's our origin. So the dog started at 0.
Okay.
And how fast did he go in the beginning? Do you remember?
2 meters per second.
2 meters per second. So each arrow is going to represent your second, and the length of the arrow should be how many meters he went in those seconds.
Okay, so this
So-
would be like 2, 4, 6.
Excellent. Do you remember how to represent when the dog stops?
By a dot?
By a dot.
Okay.
So how many dots should we have?
3.
Excellent, because he stopped for 3 seconds.
Okay.
And then if he turns around, what do you think is going to happen to the arrows?
It's going to go backwards.
Exactly, going to go backwards, and he went faster. So instead of 2 meters per second, he's going back 3 meters per second. And he should be right where he started, so you did that correct.
Woohoo!
Yay!
Yay! Okay, well, thank you for watching.
Thank you!
Yay! And if you guys need more practice, we'll do it in class. And if you really want us to do another video for more practice for you guys, we'd be happy to do that.
Definitely will.
Okay.
All right.
Bye-bye.
Bye.